All right, let's look at another. Again, these are problems from section 3.3, and I am going to direct you a little bit more to the textbook on this one. So to get to the textbook, you open the chapter contents page, you open the chapter 3, section 3.3, and then you can choose the book. There are videos for the sections also, and then you can go to the homework. So I'm doing a few of the most missed problems from last year from this particular section. And this one is number 16, which 5 people missed. If I roll over it, I can see that it's like number 37 in the textbook, which actually, as I open that, let me go ahead and look at that problem in the textbook. One thing I like about the textbook is that it has very strong examples. In fact, before I leave this, here's an example of finding the mean, median, or sorry, the standard deviation and range and sample variance, and it shows you in a step-by-step process. Plus, there's animations that help with the example here. So let's go to the textbook, page 110 in this case, where they have question number 37, and they don't only ask you to find the standard deviation and variance, sample standard deviation and sample variance. There is a difference, by the way, between population variance and population standard deviation versus sample standard deviation and sample variance. But anyway, they ask you to, they not only ask you to find it, but they give you the formula. Now, that is a formula you will be allowed to use during the test. It's on our fold-out sheet. It's worth printing out on cardstock and having with you available at all times when you're doing the homework. This formula sheet sorts the information by chapter, and then there's another review card in there that you can also print that sorts it by topic. But here is the standard deviation from a frequency distribution or frequency table. So it gives you the example of that, and it reminds you that the variance is always just the standard deviation, the square of the standard deviation. So this is a really quick reminder, and that's one of the approved handouts that you're able to use, the formulas and tables. Again, it's in the formula, it's in the Dropbox under the approved formulas and review sheets. Okay, so here they give us the question, and ours should be like this, our number 16. And here's how we know again. We know that it should be like that because it says 3.3 number 37, so it should be like 37 in the textbook. And it is. The only thing different is they've formatted this one horizontally as opposed to the textbook's example, which is formatted vertically. That's really negligible. Now, these x values right here are not the original data values because we don't have the original data values. These x values are the midpoints. So we're going to, first of all, put all the midpoints to replace these class intervals, and then we're going to use their frequencies. We're going to multiply the frequencies in accordance with the formula, and we're going to work it all out. Yeah, right. No, we're not. What we're going to do is we're going to do StatCrunch, and we're going to open in StatCrunch. It already has this list here. Now we do need to create a new list to replace these, and it'll take a little bit by hand, but I can do it pretty quickly. It's just going to be the average of each of these endpoints. Alright, and this little trick is not shown in the book, but speaking of the book, I forgot to take you. If you are not reading all the pages, you're missing some of these important pages, like page 89. The first time where it shows us how to use the various technologies, I guess specifically it starts on page 88, I'm sorry, where it shows us how to use the different technologies. StatDisk is a very good one that I kind of shy away from using as a teaching tool because it hides everything. It does too much. You are allowed to use it during the test, but make sure that you let me know so that we can open it up for you and not have you get kicked out of the test. But let me go ahead and move over to the other page, page 89. This one shows you how to use Minitab, Excel, the calculator. I've actually shown you this one in a previous video. And StatCrunch. So StatCrunch is what we're trying to use now, but this one assumes that we have all the statistics, all the data, right? We don't. So how do we get it to operate the way that it did in the previous problem. The previous problem, we just hit stat, summary statistics, chose what column they were in, and went from there. This time we're going to use grouped or bin data. In other words, use a frequency distribution or frequency table. But we have to kind of set it up, because if I try that, I'll actually just go ahead and show you. If I try to use the binned data right now, where the bins are the intervals and the counts are the frequencies, makes sense, right? The bins are like, you know, what sets of little bins did you create to put your frequencies in or your counts in. Here's an example. The 6th class interval is 45 to 51. That would be like a little bin, and we went through all the original data, which we no longer have, but we found out that there were 37 numbers that fell in that little bin or that range called interval. Anyways, if you do that, it'll say invalid format for the bins. They need to be in the format 1 to 2 or 1 to 2. So 1-2 or 1 to 2. Well, then that's not that hard to fix. So let me show you the keyboard here. One way we can fix that is to go in here, hit backspace. That will clear off the right parenthesis, and then hit the home button, taking us to the front of it, and delete. You follow me? So I'll hit enter. I'll do backspace, home button, delete. Enter. Backspace, home button. Now you don't see the home button on here, but I'm hitting home. Let me get back in my cell. Home. Or you can just arrow over, you know, you can just, I'm sorry, inside the cell you can just arrow over. So I'm hitting home and then delete. There's probably an easier way to do this. I'll go ahead and close the keyboard. You can just triple click on this, 1, 2, 3. It'll select all of it and then retype 31-37. And then for the same for the other one. So triple click 38 dash, I already forgot what the other number is, but that's not bad because I can remember it's 37 plus 7 because that's our class width. So we just go 44 and then triple click. You add each class width to each lower class limit, which would be 7 plus 38 is 45 dash 7 plus 44 is 51. I'm trying to help you remember how class intervals work. Class intervals and frequency distributions are laid out. So assume you didn't know any of this. Let's just go ahead and get rid of all of it. You can triple click and delete. How would you know what this last class interval would be? It would be 7 more than the lower class limit, which would be 52. And then 7 more than the upper class limit because our class width is 758. Okay, now it's prepared to do the summary statistics from the frequency distribution. So I type grouped or binned data, choose where my bins are, they're the intervals, choose where my counts are, they're the frequency, and choose what summary statistics you want. You can do all of this. You can do interquartile range. That will be important for the next section because you're going to need to find 1.5 times that number below to look for outliers and 1.5 times that number above to look for outliers. You can find the kurtosis and whatever the skew is. And I'm just going to go ahead. I'm going to make no changes. I've just selected what I have here. Actually, I'll make a change. See this standard error? We don't need that right now. So I'm going to go ahead and remove that. Do I hit delete? I'm not sure how to remove them anymore. I used to be able to. It's down here. I'll just leave it there. Normally, oh, there you go. You select the other way. So I'm actually going to select N. I'm going to forget about the mean, even though the mean was important because in order to find the variance you have to go through that. I'm going to choose variance and standard deviation. Now you'll notice that it's not letting me select them and hold them. I have to select and then hold control to pick them. Okay, it might seem like a lot to take in, but you've got this video that you can play and replay. Again, common thing in a computer world, computer land. When you want to select many items, you hold control and then you select the next item. So you just keep holding control and you select the next item. So those three are good enough for us. Anyway, now I wanted to ask you, why does it say that the n, or sample size, is 98? Okay, if you said, because that's the sum of all the frequencies, you are right. What we're essentially going to do is we're going to find the class midpoint for each of these, and then we're going to multiply them by their corresponding frequencies and behave as if that was the original set of data. Because remember, like I said earlier, I know that 37 numbers from my original set of data fell within this bin, or this range from 45 to 51, but I don't know what 37 they are anymore because I've lost that data. This is frequency distributions do not summarize, do not preserve the data, they summarize the data. But what it's going to do is treat all those 98 numbers accordingly. And again, I'll show you the formula from the formula sheet. It's following this formula, so it's just multiplying them out, treating them like they're all there when they're not. Okay, so anyway, there's my answer: 69 and 5/10, 8 and 3/10. Go ahead and type those in. They just want standard deviation. Okay, 8, 3/10. Consider a difference of 20% between the two values of the standard deviation to be significant. Okay, so they're giving us a benchmark for significance. How does this computed value compare with the given standard deviation of 11.1, which was in the problem? So let's see, are we 20% off or not? Is there a significant difference or not? That's really the question there. So I'll just get this calculator out and find out. The original list of data had a standard deviation of 11.1. And 20% of that, multiplying by 0.2, or 0.20 if you feel better, is 2 and 2200ths. So if I subtract that from the 11.1, that drops me down to 8 and 8800ths. Can ignore the negative. Or if I were to go above, that would bring me up to 13 and 3200ths. So I've got this 20% plus and minus value between 8 and 8800ths to 13 and 3200ths. And then I look at this frequency distribution and find the standard deviation based off of that, which is what we're calling the computed value, turning out to be 8 and 3/10. That is below even the low of those two. So the low again was 8 and 8800ths. So our response should be that this computed standard deviation from the frequency distribution of the original data set is significantly less if we're using 20% as our benchmark for level of significance. Later on, we'll usually make that a little bit more strict, and we'll make it 5% for our level of significance, but right now we're saying 20% for this problem. So if you're done, if you understand, fine. You can quit there or go back and rewind and pause and write things down and follow along. But I want to give you a little bit of a picture of what this should look like. So at some point, some original data was collected. Do we know what it is? No, it's gone, because all we have left is the frequency distribution of the data. But the original data may have had like the number 11 and then some other numbers in it. Let's go ahead and fake it after we look at the frequency distribution. So then we found this frequency distribution, and that ended up being, let's just grab it right here again. And we'll paste it right there. So that ended up being this. Looks a little better. And the original data may have really had like 11 and then a 22, and I'll fake the rest really fast, but not all of it. I'll just give you the idea. So I'm faking it with these numbers. I'll let 11 be the data value that was in the 10 to 16 interval, 22 be the one in the next interval, and so on. So there were 4 in the next interval, there were 2 in the next ones, and you might even notice that I made them from the higher end. In the interval from 31 to 37, I'm assuming that we have 35 and 37. I don't really know, and that's the point of this problem, is we don't know what they are. You know, there's 17 more there, 37 more there, 36 more there, and altogether the sum of all these values ends up being 90, not the sum of them, I'm sorry, the total number of them, call it little n, the sample size, ends up being 98 numbers. Now when we had the original numbers, the calculated value for the sample standard deviation, which we denote by S, was 11 and 1/10. Then we computed, that's why they use the word computed, computed standard deviation, over here from the frequency distribution and got 8.3. Well, if 11.1 was the actual from the original data, and we're using a benchmark of 20%, that means we go 20% below, which turned out to be 8 and 88 hundredths, and 20% above, which turned out to be 13 and 32 hundredths. And we ask ourselves, are we fitting in this range, this little 20% bubble that we have around the actual? And we didn't, because our computed mean ended up being 8.3, which was below 20% below the middle. That's why we answered it that way. We said the computed value is significantly less than the given value. All right, with just a few more minutes, I'll tell you that this one probably would have been easier to do actually in the calculator. That's why we want to know how to do a couple different versions, or use a couple different technologies. So I've already done it, and I'm just going to go ahead and show you how I did it. I went to Stat Edit, and at the start I had all these lists cleared. Then I put in the lower class limit and the upper class limit of each of these corresponding classes. Okay, lower, upper. So I did a list of the first numbers, right, and I did a list of the second numbers. And then what I did is I computed this row, and in fact I'll just show you how to do this. And all of this is online in various locations, and you can ask me, and it's also on that, I'll show you while I say it, it's also on this TI-83, TI-84 review card, and some of the other things in the textbook. The textbook has how to do all of this stuff if you know where to look. If you're reading every page, you definitely see it. You just need to dog-ear the page and come back to it. And I gave you the page for this. It's page 89. So anyway, to do this, I go up to the title on this blank list, and I choose, I do parenthesis L1 plus L2 close parenthesis divide by 2. Now, this is one way to do it, but what I'm basically doing is I'm finding the average of those two endpoints, the lower class limit and the upper class limit. Well, remember, that's going to be the midpoint. And so we're treating the x values as the class midpoints. When I hit enter, it will compute this whole list, finding the average of all of those. You really only need the first one, and then remember you can add the class width all the way down. So 13, 20, just keep adding the class width, which in our problem is 7. Then I went over one more. Actually, I'll just scoot over so you don't have to see either of the other two originals. So here's now all my class midpoints. And I could do this on paper if I'm not doing it in a calculator, or I could do it on Excel. Then I typed in all of the corresponding frequencies, 1, 1, 4, 2, 17, and so on, 37, 36. Now, go back to page, I'm sorry, 89. Find it here for a second. And look at the directions on finding the summary statistics. You'll notice that it doesn't say it here. It's actually in the reading on how to do what I'm going to do next. But there is the list of how to do it in the TI review card, and I believe I already passed it up. But anyway, I'm not going to look any further. They're in those cards. You go back to the home page and you hit Stat, go over to Calc, similar to what we did before. Single set of single variable set of statistics. We're going to do the summary statistics, where on previous problems we would just put in something like L1 because all of our original raw data was in L1. Now we're going to do L3, comma L4. So I have to hit second and those numbers each time to get their corresponding list titles. But if you do two lists, the one, whatever it is, if yours is an L1, that's fine, use L1. But whatever list contains your midpoints, do that one first, comma, do the list that contains your frequencies, then hit enter, and it will know that you're treating these like a frequency distribution, and it'll calculate, where is it? Right there, our standard deviation, our sample standard deviation, 8.3, the exact same one we had when we used StatCrunch. All right, hope that helps.